Hello friends, today we will be unboxing and testing the cheapest jump starter on Amazon. So we're going to start off with the unboxing, then I'll show you my Amazon invoice and the Amazon ad I bought, and then we'll test it on my car, which is currently dead in the parking lot, and then we will test the product's capacity, and then I will disassemble it. See right here, the cable is being compressed by the spring, which is kind of holding it in place. You can see that the cable is crimped to one side, and then there's another small cable that goes around the spring and goes to the other side. Also see the cables appear to be aluminum. Both jumper cable clamps are identical in design. See here, the cables are 10 gauge. AWG is American wire gauge, which is pretty standard for a jumper cable. And this is a standard EC5 connector. This is a 3-in-1 USB Type A to micro USB, Lightning, and USB-C cable. Now onto the device itself. The specs are printed on it. The capacity is listed at 30,000 milliamp hours, starting current at 300 amps, peak current at 600 amps. We're going to be validating those numbers together. You can see on the front here there's USB Type-C, that's for input only, for charging only, a light, and USB Type-A, and this EC5 connector, which is used for the jump starting cables. The way this is designed, the booster cable clamps are supposed to be connected to the car battery before the jump starter is plugged in. This is to prevent any arcing from occurring by you connecting the booster cable clamps after they are energized. This also allows the reverse polarity and other tests to be run before energy is delivered to the car battery. So you can see here, because I initially had no car battery connected, the leads receive no power. That's why they're not arcing or anything like that. This device should also be equipped with a self-test that looks for either the resistance or voltage from a car battery to prevent a short circuit from causing the battery to overload and potentially explode. So you can see with the leads connected to each other, I get an error and the battery does not blow up, which is good. I noticed when plugging in the jump starter cable that the battery bank housing has a lot of flex when I move the cable around. So we might use this to our advantage and use this gap as a place to help us disassemble the battery bank. Pressing the power button once shows the battery state of charge and also energizes the 5-volt USB Type A output. Pressing and holding turns on the LED to continuous or constant mode. Then we can press again to cycle to strobe, and then once again to get SOS in Morse code, and then finally once again to turn the LED off. Here we have this beautiful piece of paper that says we passed the quality control check. I cannot read whatever language this is in. On the English side is a warranty card, which I will probably not be mailing in. Finally, we have the manual. I will summarize the interesting parts for you. So the USB-C port is input only, and it only accepts 5 volts, which is like the slow charging. The Type A port allows for output. The battery clamps must be connected to the car battery before they're connected to the battery bank for jump starting. Here's my original invoice. I paid $62.14 Canadian. Interestingly, they claim this can start a 6-liter gasoline engine. It's also interesting is the battery capacity at the very bottom of this photo. It uses scientific notation. 3E plus 4 means 3 followed by 4 zeros, which is 30,000 milliamp hours. They claim this can jumpstart a car up to 40 times on a single charge. They claim that the out port can power any device like tire inflators or inverters. They claim that the enclosure is IP65 rated. And those are all obviously exaggerations or lies. I personally never recommend jumpstarting a car if you don't have to. If I had access to a power outlet, I would have bought a trickle charger and waited for the battery to charge. Because now whenever the car starts, the alternator is going to begin very aggressively charging the battery, which isn't great for it. You can see the car is 100% dead, even the dome light won't turn on. Thankfully I have this handy Chinese jump starter, which most people keep in the trunk and don't use till after the return period. I had to put the phone down for a second just to plug the cable in. Pay very close attention, the check engine light was off before I started cranking, but then was on after. Either because the car battery voltage got really low or because the car was sitting off for a very long time, the radio ended up doing a full shutdown, which is why it's taking like quite a while to boot up, and you've seen the Android boot up screen. Because we've already done a lot of cranking and not a lot of starting, we're going to follow the owner's manual recommendation, which is as follows. Step 3. If the engine will not start, the engine could be flooded with too much gasoline. While depressing the brake pedal for CVTs or the clutch pedal for manuals. Push the accelerator pedal all the way down and hold it there, then crank the engine. The jump starter battery is dead. The car battery is now charged a little bit just from the jump starter pack. So we can see right here we have 5.6 volts. That very distinct free spinning sound you hear at the very end of the start attempt is actually the motor is spinning, but the pull-in coil and hold-in coil together do not produce a magnetic field strong enough to pull the starter into engagement with the flywheel. I recharge the battery overnight and then try again. Now we're going to try and use one of the top rated jump starters from Amazon that had a Prime Day deal. This next POW 2000 amp jump starter. Now with the car running, we're going to use this blue driver OBD2 adapter to try and clear whatever check engine code the cheap jump starter set. No more check engine light array. Although my mirror dash camera continued working. This Garmin Mini 2 stopped working. As you can see, it's now responsive, and this aftermarket radio stopped working. I thought they were like broken or had a fuse blown or whatever, but I let the car sit overnight and they both are now working. So I think maybe they had an internal self-resetting fuse of some sort. I allowed the battery bank to charge overnight. Now to measure its capacity, we're going to use this Klein Tools ET920 USB digital multimeter, which will measure both the current, voltage, and the number of watt hours we draw from it, and the USB Type A to Type C adapter that was included with the battery bank. And we will be using this partially discharged MacBook Pro as our load. Right here you can see that we're doing 4.96 volts and 1.42 amps, which is kind of fine, I guess. Do pay special attention and note that the USB port on the battery bank cannot be used as output. It cannot be used to charge the MacBook. Now we're about 30 minutes in. I'm going to use this infrared thermometer to measure the temperature of things. The MacBook's about 34.3 degrees Celsius. The desk is about 30.3 degrees Celsius, which is the ambient temperature of the room roughly. The warm half of the battery is 39 to 41 degrees Celsius. That's the upper half where the USB port is. That's also where the charging circuit is. You can see 42 degrees on this side. And the cooler half of the battery is around 31, 32 degrees, which is kind of close to ambient. And the Klein Tools device is around 38 degrees Celsius. At around 7.15 watt hours drawn, the first LED turns off. We now have a state of charge of 3 of 4 LEDs. At around 14.4 watt hours drawn, the second LED turns off. We now have a state of charge of 2 of 4 LEDs. The third LED shuts off at 15.4 watt hours. At around 2 hours and 12 minutes in, you can see the device shut off with 15.65 watt hours drawn. As you can see from our testing, the 4 LED state of charge indicator is very non-linear, unlike what's described on the box and in the owner's manual. I recharged it for less than 1 minute and we regained 2 of 4 LEDs, which indicates a 50% state of charge, but we were only able to charge the MacBook for less than 6 more minutes before it died again. You can see the light still works, but there isn't enough power to charge anything with the device, so I consider it dead. See, the current voltage of the battery while dead is 13.5 volts, which actually puts it in a reasonably healthy cutoff voltage. The connector only has these 3 Phillips head screws that hold it together. can see the positive jumper cable is just a straight pass through to the connector, and there's that small red positive cable to power the PCB. Also see there's those 4 large MOSFETs. Those act as both diodes, which prevent reverse polarity, and they also allow the onboard microcontroller to shut down the black cable, effectively breaking the circuit. Using the jump starter cable I put back together, I apply like a bending force and use a flathead screwdriver to pry the case open. If you're curious why the battery bank is not glued together, it's because the housing would become a sort of projectile were the battery to swell. Instead, they prefer if the case naturally disassembled itself if the battery were to swell. These are the LED light pipes or guides used for those 4 LEDs on the side of the device. The battery is held to this side of the case using double-sided tape. Exactly as I predicted, the EC5 connector we are plugging the jump starter cables to is connected directly to the battery. The circuit board you see here is just for charging the LED light and the USB output. So I was able to remove 2 screws and flip the circuit board over. The battery you see is 4 independent battery cells that are in one shrink-wrapped case, and those are wired in series. Series means positive to negative connections between the batteries. So you can see there's one connector going to that PCB, and it has 5 pins. This is a balance cable, so the black and the red cable are likely the equivalents to what the EC5 connector offers, and they are for the 14.8 volts the battery offers. And the other 3 cables you see are likely going to connect in between each of the cells, and it allows this PCB to monitor the individual cells' voltage and to charge them individually as needed. And this prevents any individual cell from reaching a voltage that is too high while charging. Unfortunately, this has no way to interact with the EC5 connector or shut it down, so this can't be used to protect the device while it is jump starting the vehicle. Found a similar battery for sale on AliExpress. You can see it's rated for 1.8 amp hours, which is a far cry from the 30 amp hours we were promised. You can also see how the balance cable is wired. You can also see that this battery is rated for a 108 amp discharge current. In theory, this current is more than enough to start the car, but unfortunately, since we're unable to isolate the actual main car battery from the vehicle, the amount of power necessary to turn the car on is a combination of what the starter needs, what the vehicle needs, and a significant amount of power goes to charging the car battery while we're attempting to start it. Thank you for watching. Please leave any questions, comments, or concerns down below.